Looks like we have a non-multicast guy lurking in the back. Oh, okay, you're right. Your history goes way back. No, we need heckling. We need hecklers. Multi-point. PIM's not multicast. So we are top of the meat point right now. I'm sure there's some people that are in. Stig's here, first agenda list. I don't know who I would coming in. Hi, Gunter. Hello. So I need someone to take minutes. Start with that. This is where everyone looks at the keyboard and pretends they're not in the room. Anyone? Do I have to assign a name? This is where it comes next. And of course, the sad part is I assign the name of the people I know, right? So you're going to get stuck. If you drink beer with me, you're in trouble. Hi, Tim. No, I'm sorry. We're starting in the front of the house. Could you do it?
Oh, okay.
Thank you very much. Appreciate it. I need to bring back bribes, don't I? I used to bribe for minutes. That worked out pretty well.
Oh, you still can.
Okay, you'll get some of the beer tonight. How's that? Lucky you. So it's 350, right? So let's start.
Well, use these.
Blue should be in here. Retrieve them from the right time slot there. All right, Noel. Everyone noting? We'll see you note. Noted well? Excellent. Thank you. Here's our current agenda. Look at this. If you haven't seen it, please look at it thoroughly. If I've omitted something or misrepresented something, please scream. We're going to have some open discussion at the end, kind of like we did at the last IETF that led to the interim. And we're going to talk about what happened in the interim and some direction we're taking from there. So we got a lot of feedback. Is Aaliyah here? Aaliyah's not here yet. Okay. Good feedback from the ADs last time about allowing the IETF to work beyond just agenda structure and slides. And a lot of good technical solutions get resolved, or problems get resolved when we have people in the room at the same time. And it's far more productive than just the mailing list. So we're trying to use that time a little bit like we did last time. And I think it's worked out fairly well. So anything else on the agenda? We got a Jabber Scribe. We got someone taking minutes. We have a pink square here. You stay on this and you stay in camera. It's Stig. We don't have a Jabber Scribe? We don't have a Jabber Scribe. I'm sorry. We had a gap here. I misrepresented. Is anyone on Jabber? Somebody on Jabber? We have just Torless up there now and Meet Echo.
Yes, I can do details.
Can you do them both? That's two drinks of a beer from you.
What else can I
do? How much for a whole pint? All right, Stig, you're first on our list here. I will not see it. Oh, MLB right there.
All right, so I'm gonna be presenting about the IGMP MLD extension to BIER. It pretty much says MLD all over the place, but it also covers IGMP. Basically trying to come up with some dynamic signaling solution for BIER so that receivers can signal that they're interested in receiving. And one of the easiest ways of doing that is maybe to use IGMP or MLD. So the idea is to use MLD version 2 or IGMP version 3 reports, signaling queries and reports, and using that for the BIER overlay. So the idea, if you look at the network over here, you basically have some places in the network you have some multicast sources, and any BIER router that might be that you want to like send multicast into the beer domain, they need to be carriers. Basically, they need to know about interested receivers. They need to know where the multicast should be sent. And any routers that might have receivers behind them that need to send multicast, kind of receive multicast via beer, they need to be able to send reports and say, I'm interested in receiving. And we rely on like the normal like query election. So you might have multiple routers sending IGP queries into the domain. And the carriers should see each other's queries so that the one that has the highest IP address as usual can become the carrier. And anyone that has interest should send reports, and the reports would go to all the carriers. So you don't need to be the elected carrier, right? The other router that's a carrier too doesn't actually send queries. It's not elected, but it receives the reports with no settlers interest. And these receivers, they kind of need to know where to send queries. I guess I should use this. I'm actually holding it in my hand.
Top button.
Okay, cool. So the routers over here, they need to know where to send the reports. So one easy way of doing it is to just say, send to all the beer routers at all the bits in the bit set, and so every router will receive it. Alternatively, though, if you have a few routers that need to be carriers, you could configure these in some way to say, okay, when you send a report, you only need to send these bits because those will be all the possible carriers. Next slide, please. So let's see. In a way, if you want to, you could have like all routers being carriers, all routers being listeners, and everyone sending messages everywhere, which might be fine. But you can, if you want to, restrict this quite a bit. So if you know that just a few routers might be like ingress routers, you can just choose to configure those as carriers. And they need to, basically, those routers will keep state, when they see reports, they will keep state to remember where the receivers are. And they will do explicit tracking because you need to know exactly which bits to set. So you need to know exactly who the receivers are. Other routers that are not carriers, they don't really need to process the messages or do anything, or don't need to have any state. So you only have state on the ingress routers. And as I was saying earlier, those routers that might be listeners, basically those that might be egress routers, they should be configured with the BFR IDs of the carriers, so I know which bits to set when I send a report. But it could potentially be all bits set if you want to keep it easy. And basically the queries, they need to go to all the listeners and carriers. So we use like an all beer MLD nodes group for that. And then you have reports that reports only need to go to the carriers. So for that, we can use like an all beer MLD carriers group. And those groups can be any group you like. You can configure the routers with the group you want, or it could potentially be like the standard IGMP or MLD, like all carriers and all those addresses. If you want to, though, we can actually configure different addresses or have like multiple instances. If you know that certain receivers only need to receive from a few sources and some other receivers need to receive from other sources, you could potentially have like different addresses and keep those almost like two separate domains if you want to. Next slide. So this is fairly simple. Maybe the biggest problem is duplication of packets. So for example, if you have two routers that have access to have reachability to the same source, how do you figure out which of the routers should actually join to the source and send packets into the beer domain? So one thing that could help is the this draft that ICE is working on for like DF for DR election, basically choose which of the routers should be responsible. Also on the egress side, potentially, maybe there could be like 2 different routers that receive beer and send it to the same, I don't know, towards the same place in, what do you say, behind the beer domain. But whatever routing technology you use behind there, I mean, it could be like PIM or whatever. They would choose to join to one of the beer routers. So, but that's like auto scope. In a way, that's just like normal. What should I say? Normal routing. You need to decide which router to join towards. Yeah. So that's what I had. So yeah, just to summarize, the idea is what is, come up with the simplest possible mechanism we can have for dynamic signaling with beer.
So this is Greg. Let me address that directly because we already have a solution that's BGP. So we have this is not creating a solution; it's creating another solution for whatever deployment reasons why people couldn't use BGP.
Right.
So I probably in the use cases or abstract something to find.
Right.
This is kind of a problem we're coming up against quite a bit. So I mean, feel free to jump in the mic and contribute here because we often try to look for the right technical solution, which is great. And sometimes deployment is not based on technical decisions. There's reasons why they don't do certain things. Even though you might have the right way to do it, they're going to choose something else. So like we have a BGP and this is like a BGP free environment for some reason. Right. So it's having something in band, I think makes a lot of sense. At least that's what's brought this thing forward.
Yeah, so you can say there is more signaling here. You have to do like periodic signaling. But there is much less configuration and so on. So it's more like if you're in a domain where people don't use BGP, don't want to use BGP, whatever, this is like a simple alternative.
I have a comment here. I'm Jeffrey Zhang. I'm not Tony. I'm just sitting in for him today. So you mentioned the beer query or something, that term. I was really confused by that for a while because when you talk about IGMP or MLD, the querier is one particular query that's sending the queries, and then all routers will receive reports. So when you use the same term here, we're actually referring to a different thing. It was really confusing because it's not a single querier that received
right.
Yeah.
But it is, let's see, in just like standard MLD, you have like this group address that is like all
Mike.
Okay, in like standard MLD or IGMP, you have like this group address that is like all
routers,
all IGMP routers or carriers or something like that.
But I think here you point out that it's not that you want to send the report to all the IGMP routers. You only want to send those who has actually the sources connected to them. So there is a slight difference there. It's just that term is a little bit confusing.
Yeah, no, I get that. And, in some way I'm saying these are the queriers. And on the other hand, I'm saying we're electing one router to be the querier. So, yeah.
So this is Greg. Since this is basically MLD, kind of extending its use, I think we have to be very particular about the terminology and come up with something different. And that's a good point.
Yeah, I agree. Yeah.
Suggestions for a term? Not all at once.
Right,
slow
now,
down.
but...
Slow down. So, Jeffrey, I just ask you. I mean, it took you a while because you were mapping it to what the querier means in MLD. So, once you understood the machinery differences, did you have a description that you could suggest?
I need to think about that. I have not thought of good term yet.
I don't know exactly what you mean, but I can't think of anything good right now either. But yeah,
it's called not a querier.
So yeah. So by the way, also I would like input on this. What you think about the solution? But I'm also curious, if this can be a working group document.
So who's read the draft? Who thinks this is the kind of work we should take on in the beer working group? All right, pretty good response from the readers. Excellent. We'll take it to the list. Thanks, Dig.
Yep. Okay. Thanks.
Next, Sandy. And if you push the button, you don't have to point your finger. That's okay. It's not your fault. It was an entertaining Stig move. It's trying. It's trying. There we go. All right.
Good afternoon. I'm Sandy Zhang from ZTE. It's a presentation for beer in Babel.
Sorry, it's got a mind of its own.
Beer is bit indexed explicit replication. And beer introduces a novel architecture for multicast packet forwarding. It does not require a signaling protocol to explicitly build multicast distribution trees, nor does it require intermediate nodes to maintain any per flow state. I know everyone knows this. In order to forward beer encapsulated packet, some beer key parameters should be conveyed by the routing protocol. The key parameters include subdomain ID, BFR ID, Mpls info, bit string length, and so on. Babel defines a distance vector routing protocol that operates in a robust and efficient fashion, both in ordinary wired as well as in wireless mesh networks. Babel uses several TLVs to carry the routing information. And the Babel can also use new TLVs to convey beer information. This document defines a way to convey beer information in Babel. It's a simple example because Babel is a unicast routing protocol, so it is used to convey the prefix information, and such as node A. Node A will send its prefix to every node in the network. So we define the beer information associated with the Babel update advertising, and every node in the network will receive the beer information associated with the node. The beer information can be carried in Babel update message, and the prefix must not be summarized, and the according sub-TLV must be treated as transitive. Next, please. It's the format of the TLVs. The first is the beer sub-TLV. The TLV is used to carry the subdomain ID and the BFR ID. And also the second TLV is used to carry the Mpls information. And the second is bit string length conversation sub-TLV. And its format is the same as the definition in ECs. Next.
No.
Thank you. And there are many extensions protocol in of beer, such as ECs, OSPF, and BGP. So we define the Babel extensions for beer. That's all. Any comments?
Comments? So Sandy, where does Babel work take place right now? We got AD here as well.
Routing area. Routing area.
It's in Routing Area directly.
Yeah.
It doesn't have its own work group.
There's a Babel working group now.
Oh, is there?
Yeah.
Look at that.
I think it's meeting Friday?
Meet on Friday.
Friday.
Oh, fantastic. Are you
And
around
we're
on Friday?
present in-
You are presenting there.
Yeah.
Ah, very good. That was what I want to get at. Okay, so because what we've been asked to do charter-wise is we can propose these changes as the basic beer work takes place here with
Yeah.
the approval of the other group. So who's read the draft? 3 of us? So I think conceptually, even without reading the draft, do you think this is the kind of work we should be doing here within the working group? Yeah. All right. All right. This is just extending the work we've already doing with the other IGPs, and we can roll this in as well. Excellent. All right. So if you can feed back to the list on what the response was in the working group on Friday, and I'll connect with the chairs as well,
Okay.
and then we'll take it to the list on for adoption.
Okay.
It was easy. Anything else? All right. Oh, good. Here I knew you'd come out of the woodwork. You couldn't hide there quietly this long.
I can be quiet for quite some
I was
time.
talking to the guy behind you. I'm sorry.
Of course you were, Greg. Aaliyah Atlas. Babel's a little bit different than OSPF and ISIS, where the protocols are very mature and the extensibility is really well understood. Babel does have a lot of good mechanisms for extensibility, but I'm slightly twitchy about having Babel work happening here because we're still gaining expertise in Babel. So we'll have to, I think, let's see what Babel thinks about the work. I think there might be, I need to think, because I hadn't read this draft yet, I'm sorry, more deeply about what the right place for it is. I mean, it's all communication. If it's good work, we can make it go somewhere.
Good. We've got no religion on that here. As long as the work gets done with responsible people who are actually making progress, we're happy. All right.
The first, the Babel is similar with BGP protocol, and the second, the draft has,
Speaking of the mic.
the draft has been seen, be seen by Rush White, the chair of.
Oh, he's seen. Okay.
Babel chair, working group.
And you're on the agenda too, so that's good.
Yeah.
Right. All right. Excellent. Thank you.
Thank you.
Next on the agenda is update. That's me. All right. It's here already. Perfect. Okay, so a month ago, I guess, we had an interim working group meeting where actually it was kind of a design team focused on some issues that were raised in Berlin. Namely, looking at our charter, we are chartered to provide solution with a single encapsulation, which was Mpls coming forward from BOF and into the architecture, and one more. But a lot of stuff came out, a lot of drafts were written, ideas were thrown around. What we really needed to do is focus on understanding the use cases first that were not addressed by Mpls encapsulation. And if there was a single encap that would be addressed by something new, that we'd focus our efforts, consolidate the drafts, and move in that direction. What we found out, though, is that, I mean, we knew this, but come to a conclusion that there's nothing really about Mpls in what we do with using label encapsulation, right? There's no LDP running. All it is just hop by hop telling it which table to point to. So there was we looked at that. We looked at the generic Ethernet encapsulation draft, and with some flipping order of some of the fields, we're able to reuse a space that would work both in generic encap and with Mpls encap. ICE is going to go into greater detail presenting what we've done with that, but the takeaways were Tony jumping on the parties, making sure all the contributors work together towards a solution. The draft and the slides were all shared amongst all the stakeholders in advance, so hopefully there's no surprises today through the process, and we continue to move forward holding hands and singing Kumbaya. So we also had the draft that Stig just presented, MLD draft, and there was some work on the VXLAN draft that had some similar solutions with in-band signaling. So we asked those two groups to work together and move forward with ICE and Pierre. And now we've got Stig involved there. We had meetings earlier this week with engineers from ZD that had the solution. And I think we have direction now on who contributes what to make this unified draft move forward. By the way, who was actually on the phone or in the room? Do we have representation here today? At the interim meeting. Yes, young lady in the back. We had Stig. Yes, see we're there. All right. So we got fairly good representation. Is Dino here? Dino's not here. All right. So what? I'm probably a biased source on this because I put this thing together, but I think it was incredibly productive 2.5 days. And getting people in the room and make it happen is so much faster than miscommunication in email threads, as asynchronous as it is, and it seems to give us a lot of flexibility, it doesn't focus us on getting something accomplished. And it was fairly free form, but I think we were able to keep the cats in order and made some progress. And so they're the takeaways. These takeaways were actually on the list as well. So this should not be a surprise to the room at all. But I'm prefacing the next couple of presentations and kind of putting this in context. And then the discussion we'll have afterwards is kind of taking the context here. So this piece actually has not been addressed yet. There was a use case for host-to-host kind of signaling. And we have the takeaways here. I understand it's been only a number of weeks and there's other things to do. But consider this a kick in the pants to move this stuff forward as well. Otherwise, it's going to rot on the vine. And the big one issue was really, if they're not encapsulating with Mpls or refuse to for some reason, and the generic encap for some reason, which can reuse those fields, was not adequate, what else would we do? And now I don't think anyone came up with a solid technical reason why to do something different, but there's definitely operational reasons why somebody would do something different. There may be platforms that are limiting in some way, which is kind of an odd argument because it's a platform rev to support beer anyway. So if you have to rev your platform to support beer, does that include the encap required or not? It should. But there's still going to be environments, potentially data centers, potentially enterprises, and well, those two cases primarily where they're all moving toward a 6 only solution. All of their technologies are moving towards a v6 solution, and they didn't want a label-based mechanism inside their network. Now it's kind of odd because it really becomes marketing at this point, because just call the label something else, right? It just happens to be called label, so people think MPLS, but that's already, what, the cows have left the barn. However, Pierre had a really interesting use case that was beyond just encapsulation, and it was a bit of a hybrid between actual v6 forwarding and beer forwarding using the v6 header. And that's a use case that could not be addressed by just a label. So we've asked Pierre to take this to the v6 community at large, get some better feedback. I think what, at least my experience, and hopefully his he'll clarify some of this, there was a lot of sense from the beer-only folks that the v6 people were going to freak out over this, that we violated something in some way. But I've been speaking to some v6 people afterwards. They said, hey, that's kind of clever. That sounds kind of cool. So maybe we were a little too apprehensive, and we might have a better sense of a direction going forward from this week. So hopefully we'll get some feedback. With 6-man's tomorrow, though, right? Tomorrow morning. So unfortunately, we can't feedback there today. However, after you see his presentation, if this is something you think you're motivated to contribute in some way, or have some backing information on the use cases why you need this, please go to 6-man afterwards and make your case there to help us along.
A clarifying question here.
Sure.
So the IPv6 encoding, is that tied to the host-to-host use case, or is just beyond that?
It could be, but it's not tied to that. The particular host-host use case was in breaking the DR election mechanism primarily, wasn't that it? Where we currently have timers associated with PIM doing something and IGMP doing something else, and we didn't want to have to run PIM in this environment if the imposition was happening directly. We could point to a router and go straight in that direction. But once it's past that first hop, it's a v6 packet potentially, or it's a beer packet, depending on the domain. So they're overlapping, but they're not dependent. In line? All right. So that ICE is next here with, I need to go back, architecture. Hey, and I have the slides here. Yeah, it's that button.
Yeah, so flip.
No, you can't do, no, I'm not plugging it in.
It's this one, huh?
No, it's this one. Yeah. I don't take random memory sticks and shove them in my laptop.
Cool.
Well, this is ugly. How'd you manage this? There we go.
What did I do?
I found the button.
Cool. Hey, I'm Mike from Cisco. So small update on the beer architecture draft. Next slide. So the architecture draft currently has the BF4 ID, and the BF4 ID is actually a function of the number of sets that you have and the bit string length, because it's the set ID times the bit string length is how many BF4 IDs that you can have in your network. And both of them are variable. So also it's maximum up to 256, but the draft actually says that 16 is a must, and the rest is, preferred, is a may.
I'm sorry, can you come to the mic? Yeah, if you get a question, please come to the mic.
So the minimum of the bit string
Name,
is,
start with your name.
it's David from Mellanox. So the 16 bits is become the minimum. Sorry?
Name again.
Name again. What's your name?
David from Mellanox. David Moses from Mellanox. So it was 256 bit at the beginning, and now it's 16 bit is the
No,
minimum.
so it has always been 256.
Yes.
Like it's an 8-bit field, but in the architecture draft, we defined that the minimum supported length is 16, right? So you don't have to implement support for 256. The minimum is 16, but of course it's recommended to support the whole range.
Okay,
That didn't change.
so it allowed to support, 16, 64. It's okay, less than 256. Okay, that's cool. Good.
Yeah. Next slide. However, the architecture draft says that the maximum number of BFR IDs was 65K. But obviously, if you have a bit string length of 64, right, and you implement 16-bit set, not more than 60-bit sets, then you don't reach the 64K, right? So we updated the draft to point out that the number of BFR IDs that you actually can have is a function of the number of sets and the bit string length that you have, and that was pointed out by Xiao. So thanks for that comment. So that's what we updated in the architecture draft. Any questions on that? No? Okay.
We're just to clarify for the room and for the rest of us too, there were no architecture changes based on the interim meeting though, correct?
Correct. Yeah.
Gotta be kidding. How do I get rid of this thing?
You need any help, Greg?
Yeah, I do.
This,
Pardon me?
you knock this off.
Yeah, I did intentionally, so I can actually get the rest of my interface here. That's crazy. And now we need Mpls and cap. I'm getting there. There we go. All right. And Mpls. Is this going to take over my machine too?
Yeah. Unfortunately, I cannot sing. Otherwise, I could sing a song for you to keep you entertained. But I'm sure it will be entertaining, but embarrassing for me.
Well, how does it do this? What does this do? This is
Where's the
crazy.
blue sheet?
All right. Cool. All right.
You got to be smarter in PowerPoint, and I'm not.
Okay. So yeah, so this is an update on the Mpls encapsulation draft, or a proposed update actually, because we haven't made any changes to this draft, because a lot of these changes that we're planning to do are actually based on the interim working group meeting that we had a month ago or so. So before we actually start updating the draft, we wanted to run this by the working group and see what the input was before we actually do the work. So as Greg also mentioned, so there's a couple of questions or topics that we discussed, like is there a need for a second encapsulation, right? What's wrong with Mpls encapsulation, and what are challenges with Mpls? Now it's really hard to have those discussions without getting to religious areas or political areas, or because having a discussion about Mpls versus non-Mpls is bigger than just beer by itself, right? So a lot of times it's maybe even a company policy to say, well, we don't do Mpls. Right? So it's really hard to come up with technical arguments against why you would not, or you would want to do this. Anyway, so we moved forward still. Next slide. And we just said if we want to define an encapsulation which is not based on Mpls, what are the requirements really? How would you do it? And one of the main requirements that we really all agreed on is that, okay, if we do that, it must have as much as in common with the Mpls encoding that we have today, right? So you have as much common fields as possible, so you can reuse a lot of your logic or your hardware for this. Also, we don't want to have any hard-coded set ID and subdomain fields in that encoding, right? To keep it very generic. Next slide. Also, the only really Mpls gap that we sort of came up with is I think it's called the COS field in Mpls, because that's only 3 bits. But that's not enough reason actually to define a second encapsulation, right? That's not why we went forward with this. Next slide. So we did look at the existing Mpls encapsulation, and by the way, you see this is the encapsulation that's in the draft with the Mpls header on the top, right? With label on the top, because with beer encoding, there's really one label at the top with the end of stack bit set. So this is really what the full encoding looks like, right? Now the green part is really the common part here. And so we looked at this encoding, and let me point you to the reserved fields here. The reserved fields are really useful, and I'm going to show you how we're going to use it later. But they're pretty far down into the packet, so you have to go past the bit string in order to get those reserved fields. That makes them more limited in use because this will be something that you want to use, at the egress and not potentially at the midpoint potentially. So we thought it was better. Next slide. To do this. So we moved that line that was previously here, we move it up to the beginning of the packets. So these reserved fields are now more accessible, and you don't have to pass through the whole bit string to get to the reserved fields. We thought that was a pretty good change to the encoding. Now, so this really becomes our generic encoding. And go to the next slide. This is what we would propose for a beer encapsulation that does not use Mpls. Now, you see a lot of the fields are in the same place, and we use the reserved fields to encode the DSCP value, because that's something which is not in Mpls, but it is used in IP. So we can satisfy that requirement. Also look at this BIFT ID. Now, the BIFT ID is really the beer forwarding table identifier. And it's a 20-bit value here, so it looks like a label here. We made this also reserved. Next slide. Now, so this BIFT ID really identifies your beer forwarding table, and each bit string length, subdomain, and set ID has its unique BIFT value, right? So it's really sort of used as a label here, right? It has the same function. It's a table identifier that you use to look up your forwarding table in hardware. Also, so each router needs to be aware, what that mapping means, right? By the way, these are still the old slides.
Would you send me new ones?
This morning.
Oh, sorry.
Anyway. Next slide. Now, that 20-bit space, you can still use that to specifically encode the subdomain set ID and the bit string length. So it functions sort of, as a fixed value, but your implementation should not depend on that, right? So for the forwarding lookup, it is a value that identifies a table. Let's say how you use that value or how you create that value is really up to the control plane. Okay, next slide. Now, when we use this non-Mpls encapsulation, you could potentially implement this actually as an Mpls global label, right? So this table ID is really, a domain or network-wide unique value, right? It needs to be unique among your network. So you could use an Mpls label for that, but that means your Mpls label has to be also, network-wide unique. And we know there are issues with that, right? Because not, all the platforms, not all the vendors support the same label rates, right? So if you don't come up with the same value that is used on different vendors, that may be an issue. And with segment routing, we've seen, those issues too, right? So that doesn't necessarily solve that problem. Also, if you would actually implement it as Mpls, it's possible that the router has to support Mpls and non-Mpls beer encoding, right? So, and you definitely don't want those values to be overlapping because that will get you into problems. So we're actually leaning towards then coming up with a new ether type encoding for beer. So for the non-Mpls encoding, we get a different ether type, so you never actually interfere with the unicast Mpls space. Next slide. So here's summarizing the proposal. So we modify the Mpls encapsulation, to make the reserve bits more accessible, right? So we use some of these reserve bits for the DSCP value. The Mpls encapsulation is really the basis for a common beer encapsulation. Basically, the label and the BIFT ID have the same function, right? It's a table lookup that you do. And if you want, you can actually make this with the value. You can carve it up into well-known fields by the control plane if that's what you want to do. Next slide. Now, another thing that we discussed during the meeting was the type field. The type field, I think, is 4 bits now. So maybe that's too small. So, but we do have enough bits we can extend it. But we haven't really made up our mind yet, if that's what's needed. But we could. So as I said, we can allocate a new ether type for Ethernet encapsulation. And what we plan to do is we document these changes in the Mpls encapsulation draft. So we want to use a single draft to document the Mpls encapsulation and the non-Mpls encapsulation such that the common part is defined in a single draft. That's it. Next slide. Questions? Questions?
Yeah, it's Andrew Dolgano and Nokia now. Nokia, yeah, I would say Alcatel still. Hey, so this is Andrew Dolgano, Nokia. This is actually a pretty big change. I know that moving the fields around, especially if we need to do the MPLS and non-MPLS in the same hardware and moving stuff out. I'm not gonna say I'm opposed, but I'm concerned with that and flexibility of hardware now that we'll need to do, because we already have requirement to deal with multiple bit strength lengths, because not everybody will likely implement a single value. So did you guys look a little bit, sorry I couldn't make the interim, but did you guys look at it at somehow minimizing that change? Because we're moving quite a bit. And I would rather keep the values at the back, because then you have the way the MPLS header has it, because that way a lot of common processing goes the same way, and you have to dig out. Like saying that it's too deep in a packet, I don't think it's a real true argument, because you have to go there anyways. So you have no. That's a pretty weak argument to me. You have to go there to get the entire header anyways. So I'd rather keep the header form different, the same, reuse the fields the way you were using them. There's nothing wrong with them, but kept the header as similar as possible, because this is the same as flip the IP addresses, source and destination, and somebody may say, oh, same header. Well, there's quite a bit of difference, yeah.
Yeah. Well, yeah.
So I wasn't
agree.
at the meeting, so there may have been a valid arguments that I'm not privy to right now.
Well,
but if I was to vote, my vote would be to keep the header type the same, and unfortunately bury that DSCP deep. Well, we still have to go that deep.
Right, but I think the argument to keep those DSCP values, that it was more beneficial to have them earlier in the packet versus at the end. But yeah.
You need the fields after to forward. So first you need to forward, then you need DHCP to add at top of that forwarding. Yeah. So
yeah. Okay. Good point.
Robert Raszuk. So I have a question. On one of the slides you said with the new encapsulation header, you are leaning towards new ether type. Yeah. What options do you have? I mean, if it's leaning towards, because actually, the reason I'm asking is, I like that you want to separate from 8847, and because it is actually beneficial to deploy BIER with completely new data plane, and you don't inherit any bugs and problems, right?
Right.
So,
yeah, it's like, if you do not want to do MPLS because there's no MPLS, then we thought well, there's nothing to worry about then, right? You can just reuse that field, and if there's no MPLS, there's nothing to conflict with, right? But then, of course, if you say, well, if you have to do MPLS and BIER together, and you use BIER without MPLS encoding, then that becomes an issue, right? So you other options are make sure that BIER gets a different label space that you can use now as values that you allocate.
It will be still 8847, so it will be still MPLS.
Yes, but if you can carve out your label space, right? You can make it unique, right? But it's more hacky, right? It's cleaner architecturally to have another ether type. So, yeah.
We've gone full circle on that.
Other comments, questions,
Comments or
concerns?
questions on that? All right, so, Andrew, this actually has me concerned. I mean, that's a real issue to bring up, and it didn't come up in the interim. The interim was publicly available. All the minutes are out there as well. But I would like to, get your buy-in or resolution on this in some way as we move forward. Yeah, please. Okay, so you guys will integrate with the rest of the players on that draft as well.
Okay.
All right.
Thanks.
Thanks, Ice.
Who has the bullshit?
We're not done.
Who has the bullshit? Sorry.
Blue sheets. Who's got the blues? All right, Pierre.
Hello, everybody. So this is the update on the beer over IPv6 draft. We have 1 hour to go, so I will try to be very slow. So this is an update, although I didn't really present it yet in the meeting working group, but we already we presented. I mean, we talked about it during the interim meeting. So just a quick recap of what it is, so that everybody is together. So the idea is, as was said, as Greg said earlier, that all networks may not want to deploy the Mpls encap, maybe not the Ethernet encap, and if we are chartered to do a second encapsulation, I think this encapsulation should be future-proof and try to make one over IPv6 seems to be the most obvious option if we have to do a second encapsulation. The idea of this encap is really simple. Well, you use the IPv6 header, and you want basically to put all the information that you need to do beer in the IPv6 header. And obviously, the most important part are the bits, the beer bits that you put in the destination address at the end of the destination address, and everything that comes before gives you the subdomain ID and the set identifier. Next slide. So this is not going to surprise anybody. Really, it's very simple. At the BFIR, you receive a multicast packet, and you want to encapsulate that packet into a beer packet, and that beer packet is actually just an IPv6 packet as well. So this is an IPv6 header. I mean, you add an IPv6 header, so it's going to be IP in IP in the end. But within this IPv6 header, the destination address actually includes the beer bits. That's as simple as that. And then when the packet gets forwarded through the beer domain, the bits that are in the destination IP address are modified, just like beer does as usual, such that it reaches the BF egress routers. And when it does, you see that each BFER is assigned an IPv6 address, basically, which has just one of the bits, the beer bit set. Next slide. So that particular point is actually fairly interesting, because that means that your BFER is going to receive all the packets, all the IPv6 packets, where the bit that is assigned to this BFER is set, just like in any case of beer. But if you look at all the packets which destination is that address where just one bit is set, you realize that this packet is just a unicast packet, and it's forwarded by the beer algorithm, but it's actually exactly the same output as if it was forwarded by the unicast forwarding algorithm. So that means that you can send packet that looks like unicast to some BFER that is forwarded just like unicast, and that is actually beer. The second advantage of this approach is that, as I said, your packet looks like a unicast packet, and at the beginning of the destination address, you use a prefix, and that prefix is going to sort of identify your beer domain, the subdomain ID, and the set identifier. But that also means that you can use this IPv6 prefix to route the packet by unicast, by using unicast forwarding towards your beer domain. So before the packet gets forwarded, before the packet gets duplicated, you can route it as a unicast packet. Basically meaning that you can do multicast through the global internet. You can send a multicast packet from anywhere. That multicast packet is going, I mean, beer multicast, that packet is going to be forwarded as unicast towards the beer domain. And once it enters the beer domain, it gets duplicated just like any beer packet. Next slide. So that was mentioned earlier. MPLS and Ethernet encapsulation are going to be merged. So the working group still has some space for another encapsulation. I think the IPv6 encap is fairly interesting in that sense because it provides additional features, as I just explained. So maybe it's, I mean, I don't know if there are also other proposed encapsulation, but as far as I know, this one is the only other encap that has been proposed since the MPLS and Ethernet encapsulation are now merged. Next slide. So just to mention the update, the update is the biggest piece of the update is similar to the update in MPLS actually. So in the previous draft we had within the beer IPv6 prefix, which means the highest weight bits in the destination address, we had clearly mentioning beer prefix, subdomain ID, set ID, but this is not really necessary. Really what we need is an identifier which gives us all this information doing a lookup, hardware or software lookup, which gives us from the prefix, the set identifier, and the subdomain ID. So this is what we do. We just use the prefix. You can use the longest match prefix or not. I mean, if the prefixes are disjoint, most of the time they will be disjoint. But the idea being that to make the difference between a unicast packet and a beer packet, this is going to be done by the usual longest match prefix algorithm. And once you do this match, that gives you your subdomain ID and the set identifier, therefore giving you the bit string length as well, such that you can operate as on the beer packet as a beer packet. One of the changes as well was a terminology error mistake that I make, changing the routing underlay towards beer layer. That was just a stupid mistake from me. And there was some wording clarification. Next slide. One thing as well that needed to be mentioned is that this proposal actually doesn't conform to the architecture draft because it doesn't allow you to implement a 256 bit string length. And that's actually a point I would like to discuss with you today because maybe there is something to change in the architecture draft with regard to that because, right, the architecture draft fits exactly what's needed in the MPLS and Ethernet encapsulation. But what about the cases where, like, for instance, networks with small MTUs or these kind of things, you may not always offer to have 256 bits in your packets. And I mean, the beer over IPv6 is an example where you cannot just, you don't have the space in the destination address to put 256 bits, obviously. And really that doesn't look like the kind of thing that should be in the architecture draft, but rather the kind of things that should be in the solutions draft, the encapsulation draft. Next slide, please. So the next step. So tomorrow I'm going to present to 6man, see if this solution breaks anything. I mean, see if the feedback from the 6man working group. As I mentioned, maybe the architecture draft should relax the requirements on the bit string and those strong requirements that are necessary for interoperability between MPLS beer routers and Ethernet beer routers. I think those requirements on the bit string should go to the MPLS and Ethernet encapsulation documents because I think they are really specific to those encapsulation. And finally, I would like to know what you think about this proposal. If you think this should be the other encap from beer, or if you have other proposals, or if you just think this is not a good idea. Thank you.
Tim Joan, give me time to get back to type the answer that you give me. The first question is, It seems, therefore, that the destination address will change potentially hop by hop as the packet moves along and the replication bit string changes.
Mhm.
I guess that's not a problem at all. It's just a bit unusual. Okay. Okay. The second thing, which does it really matter that you're not using a 60, the assumption of the 64-bit boundary? I guess it doesn't, maybe until you get into the final domain. I don't know.
Well, the 64,
are there some assumptions in that boundary?
The 64 bits boundary is more applicable to host configuration in general. That's where it's involved.
But if you're still relying on the routing part of it to get it to the final.
Oh, I hope your routers do not have a 64 bits boundary hard-coded anywhere.
I doubt they would. But there are a number of assumptions that.
Mike.
I think it would be useful to go there. Well, there is the Y/64 draft. It might be useful to go through that, thinking about this and whether there's anything that would pop up that you need to
I think,
consider.
Yeah, I know the Y64 RFC now, and I think the only hard requirement is about Slack. The rest is mostly informative and generally not really problematic.
Lawrence Kaludi, since sorry for not saying that there, Mike. I'm not sure if this is relevant, but there are routers that just don't do well with stuff that's with prefix lengths that are greater than 65. They just don't. Basically, they will do stuff like reduce your TCAM number, reduce your number of routes that they can store by half, right? Because
it's actually a good news, because in the case of beer, I don't want to use prefixes longer than 64. I mean, you want to have as many bits as possible. 64 is a reasonable number. You may want to get more than that, but fewer than 64 bits is really not a lot.
David Lampeter, have you thought about what will happen if you get ICMP errors back to the multicast source for quite a few of the packets that you're forwarding from possibly quite a few places?
You mean you want to put a multicast source address?
No, if a packet is being forwarded by this mechanism, it looks like a unicast packet. So it might get error handled like a unicast packet, which is to send ICMP messages, which could come from multiple places at once for a single packet if it's already gone through replication.
That's similar to multicast.
Yeah, but for multicast, you don't really do that.
Oh, if I address that, it doesn't transition back. So it's being forwarded as unicast till it gets to the beer domain. If there's any ICMP errors associated with the unicast forwarding at that point, there hasn't been any replication. Once it gets to the beer domain, it's not forwarded as IPv6 unicast any longer, right? It's forwarded as beer.
Okay, so you're assuming that once it's replicated, it won't be tunneled again.
Correct.
So, okay.
I'd add, correct me if I'm
name
Mark Townsley. Correct me if I'm wrong though. The source that's sending this packet, that's a unicast packet that knows that at some point it's going to hit something and start getting replicated according to its destination bits, probably knows that that's going to happen. That's why it chose that destination address. And if it receives a bunch of ICMP messages because maybe there was a bug in the beer domain, then maybe it can handle it. It might be something to consider in some considerations section as this experimental document. It's what you would find out in an experiment, in fact.
Wave your hand some more. Lots of hand waving. Wave lots.
Yeah, I'm not worried about the handling of receiving such packets. I'm just worried about that there could be a lot of those packets if you're mixing replication and then tunneling again. So if you're replicating and then crossing another unicast domain, that unicast domain can send your ICMP messages, and there could be quite a few.
David from Mellanox, just for your questions, I really support to reduce the 256-bit string requirement in the architectures. As I mentioned earlier, I think it's going to do our life much easier if we support less than 256. This is one thing. Second thing, in the previous meetings, there was some discussion to come with use cases for beer, with a list of use cases for the data center, with draft, with something that we can be more, stay to the ground? And any progress with that?
Yes, that was taken to the list. That those use cases were then brought to the interim meeting, and we addressed them there. If you've got other use cases to bring in, doors are open, ears are open. Please add more to it. But what we were really focused on was not like trying to boil the ocean with use cases, but trying to find those overlaps where MPLS didn't fit, and we needed to do something else. And if we define that list of something else, what would address them? So that was, it wasn't just trying to find different use cases. It was specifically to find use cases that weren't addressed by the current documented Encap.
Yeah, I understood, but we have this list of use cases.
Sorry?
We have this list of use cases in the list.
It should be, yeah. I've got it on the original agenda for the interim meeting, so I can rehash that on the list if you'd like me to.
Okay, it's really good. Thank you.
Actually, back to the mic, because this is a good point. This has been handled through email communication, which is probably not the way to handle this. Maybe we should include this in
the agenda, I think. Yes.
Well, not just the agenda, maybe in a draft of some way that
yes.
A living document that we can start working towards.
Sure, I think it's the basic. I mean, that we have what we are doing with this. What is the use cases?
So what do we have a use cases draft? Who is the current owner of the use cases draft?
I don't know.
I should know this at the top of my head, and I don't. And no one's raising their hand. Who was that? Ah, the Hendricks got it. Okay.
Just fast, very minor. Oh yeah, just suggesting you can always document this stuff in the wiki. That's kind of what it's there for. So just a lot of what you had for the agenda was a little bit of brainstorming use cases. It seems like it's not quite solid enough for a draft yet. So use the wiki, please.
Use the wiki. All right, that's my new go-to answer for everything now. If you can't solve it with a controller, solve it with wiki.
Mark Townsley again. I'm going to make a comment that is a bit of a use case, but it's also to let you know. I'm going to ask Pierre to go back to the architecture recommendation slide, the one where small MTUs or something. In terms of use cases, somewhere. Anyhow, I've seen replication and explicit replication used in IoT context, and there's very interesting things there. And it's what I like about the work that Pierre's done here. Not only is it something that might actually end up being useful and deployed and stuff like that, it's causing this group to think a little bit more out of the box than when the original architecture was written down, perhaps. And the IoT space, unless it's going to start, being, MPLS enabled or something, could benefit from an IPv6 encoding because of the 6LoWPAN adaptation, as well as small MTU is obvious there because there's 128-bit or whatever, or byte MTUs and such. So, I think it's going to help your overall architecture if you consider this in the working group, because it operates at a different layer and perhaps in different domains.
Can I just offer the concept that beer itself was totally outside the box to begin with, so we had no box to be thinking outside of?
Nice.
There is a pink box. Oh, that keeps you on camera there. And then if I push this red button, the floor drops.
I was wondering.
Yeah, there it is. I didn't miss any participants. So, unfortunately, with one mic, it's a little tough. Thanks for jumping up here when I pointed out. It's kind of hard to have a dynamic conversation with a single mic and have to record it, but this has been really good. I think we've got good traction. I think, like I said, we got a 6 input here. We got 6 input back there. I'm really excited about this. So people, from a beer perspective, replication perspective, you think this is a use case that we should consider in the IETF or within this working group, please participate tomorrow at 6-man. If there's some people, because oftentimes you find, you guys know this, right? You're multicast people. You talk to people who don't play with multicast, it's like, oh, that's out of scope. They just toss it in the pile and then they never address it again until people like us jump in and help out. So we need to jump in and help out. Otherwise, it's going to be a 6 unicast focused only discussion without understanding what we're trying to solve with this solution. So if I can, I was hoping to have a little more free-form time, but I think we got to some good conclusion here already. What I would like to bring up is just, if anyone could volunteer their input on the success or failure of the interim meeting, so we get some feedback to the list of people who weren't there and encourage people to participate if and when we need to do that again. So the people who are actually at the interim, willing to at least step up a bit of the mic and what you thought worked or didn't work about the process, I'd appreciate that. People don't mind me putting you on the spot here. We got Ice, we got Stig, we've got, who else was there? We got Pierre, who's already at the mic. Anyone else was there? Jeffrey was remote. Can you talk about that experience remote? Were you able to track it, or something we did right or wrong?
Well, it's just technical difficulties, the mics. Yeah. That's the only thing.
It's funny how many of us were in the AV club in middle school and we still can't get that crap right. The technology moves, and trying to get it together, getting the mics in the room in the right place, getting the ability for people to remotely participate and interject. We still have not perfected those tools to just drop in and go, but it did get better. We brought a better mic in, we got it directional. Anyone else? At least, Ice, can you give some feedback? If I put you on the spot here, do you think the interim meeting was successful? Did it work? Didn't work? Oh, you have comments? Well, we're still talking about the conclusion for the interim. So yeah, we can ask him to sit down if you want to. You can come up here or over there. I wasn't asking. Unless you want to stand in the pink box, I hit this red button. Sorry, Pierre.
So yeah, I found it really actually very useful, the interim meeting. Because otherwise we probably spent a lot of emails going back and forth and discussions on the list, and actually being face to face in a meeting and talking and whiteboarding, I think is a great way to do these things. And it obviously really helps if you have like a very specific topic that you want to discuss. Yeah, unfortunately, maybe we missed Andrew, I guess, in that meeting. That would have been helpful. But yeah, so for me it was a great experience. My first interim meeting I actually had at IETF, and I've been at IETF for a while, so I would definitely recommend it. So that's. I love it. Yeah.
Thanks. Mark, so that actually is the end of our agenda, unless you had something to add? Okay, good. Please.
Just a quick one before we close on this one.
Okay, good.
Since we close on the interim meeting, I'm assuming nobody's against relaxing the architecture draft to allow this, yeah? Because can we change? Can we just, or do people have? This is relatively, it was relatively controversial. I think it's a good idea to relax it, personally, in my opinion. But like maybe it's worth having a discussion if people disagree.
Yeah. So I agree. So I agree with Pierre here that currently the architecture draft actually says what the encoded values, the possibilities are. But this is more a function actually of the encapsulation itself, right? So with Mpls, we define these values, 64, 128, up to 4,000. And I think that we can move that to Mpls encapsulation draft. So, well, if you use Mpls, these are the values. But I think in the architecture draft, we can probably relax that.
Yeah, I agree. But I think also there is inconsistency between the architecture's draft and the encapsulation draft, because in the architecture draft, it says 256-bit as a recommendation, and in the encapsulation draft, it says 64. So,
no, okay, I'll look it up, but I don't think that's the case. I think 256 is recommended, right? But other values are allowed.
Oh, okay.
But we're not saying that 64 is a recommended value in the Mpls encapsulation draft. I don't think.
Please no.
Like I think we should. Personally, I think we should say remove the max in architecture draft. Say you need to be flexible and you must support encapsulations as per encapsulation. Just general statement, and then in Mpls we'll lift the text from architecture draft and we'll just put it.
Yeah.
Like we don't want to reopen this. I don't want to yet reopen the discussion for that. We had discussion. We'll just lift it and put it back into Mpls draft with the existing values, and then we can address this in the next one. Yeah.
Young man.
Okay, now I'm back.
Yeah.
The reason I was up earlier was I wanted to go clarify the next step. So now that we've started, should this be the other end cap? I know we need to go talk to 6-man, but assuming they don't come up with some conclusive, like, no, can't do it for these reasons, we all agree. So assuming that goes, positively, should this be the other Encap? It
Show
might
of
be good
hands.
information to even have in his pocket when he goes and
Yeah.
talks on Tuesday.
Good question. So show of hands, who's read the draft, first of all? All right. And even without reading the draft, I think you can kind of grok what we're trying to solve here. So who thinks this should be the candidate for the next Encap? All right. Who thinks absolutely not? Oh, we have one no. All right. One abstain or one reject. Yeah, dude.
Tim Chan, could you say why you don't want it to be?
Good question, Tim.
Xiaohu from Huawei. If you want to make a big change to the Mpls beer encapsulation, why you still propose this?
Well, first of all, we're not trying to make a big change. That's not the motivation here. What we have is a use case specifically to V6, where we can actually do hybrid forwarding of unicast to a V6 to a beer domain, and then beer down from there. So that's a unique use case.
Yes, if you want to propose alternative beer encapsulation, we may need to validate whether that use case is significant to propose a new encapsulation.
Which use case? I lost you there. Sorry.
Yeah, I want to confirm what's use case for the IP.
Did you
IPv6
see the presentation?
Yeah.
Let's go right back to the diagram. Then we show it right
yeah,
there.
you want to
that use case.
You want to forward the beer packet and normal IPv6 packet until it's reach the
correct
beer ingress, right? Yeah.
I think you're misunderstanding. Beer is a concept that can be encoded in any set of bits that you choose to encode it in, and it's that function is being encoded in the V6 address. It's not a beer header.
Yes.
It's just using those bits in the V6 header because there's a V6 header. You can still do MPLS and you can still do beer in MPLS. This is beer in V6. Yeah, exactly. You're seeing this again and again.
Right.
L2 VPNs, L3 VPNs, it's kind of congruent to segment routing. It really is.
Yeah.
Yeah.
And to your point, Mark, we're not just re-encapsulating the existing beer header.
Yeah, you're not re-encapsulating anything. It's just using that concept.
Encoding
with
beer
those
into
bits.
a V6 packet or V6 header, which also gives us encap.
If you want to traverse a non-beer domain, why not just use a tunnel? There's no need to propose a new encapsulation.
Well, in that case, you do not need a tunnel because the source can just send a packet that is not tunneled. That's going to work. So it's a feature. I mean, you do not need a tunnel. You can have a source that sends packets that are not tunneled, meaning that they don't need to know that it's a beer packet. They could send a, I don't know, UDP packet that happens to have a beer destination. So multiple destinations are going to receive the packet. The source doesn't need to know that it's a beer packet. These kind of things.
I think this just illustrates maybe it's worth to just spell out the use case because people get confused, I think, what we're trying to do here. And that, there's nothing to say because there is confusion.
Yeah. Thanks. So, right. So what Andrew said is also so we talked a little bit about use cases, and we started at the intro meeting to talk about use cases. And for me, one of the use cases for this is actually if you want to do beer starting from the host, right? Because actually any application today that supports IPv6, you can put in a destination address that now is a beer address, gets treated as beer in the rest of the network, but from the host side and the application side, nothing needs to change, right? So I think that's one of the attractive use cases actually for this, which you cannot do with any other encapsulation, because if you change the encapsulation, well, you need to make support for that in your application.
Make host changes and application changes, right?
Yeah. So.
It's a good spin there. All right. Anyone else? Blue sheets.
Has anyone not signed the blue sheets?
Good discussion. Thanks. Oops. I think we've got working group support behind taking this to 6-man. And if 6-man embraces this with all the love and affection we would like to see, then we've got the support of the group behind you here. And we'll be there quietly in the back applauding you. So 6-man tomorrow morning, please. Hey, how are you? All right, doing well, thanks. Did we bring it to the list? Oops. Oh, the BGP draft, BGPLS draft. Oh, right. Okay. Ouch! I slipped through my fingers. So I did I take it to the list or not? I probably didn't, did I? So we asked in the room.
Yeah, you have asked last week.
Gotcha, but I didn't send it to the list yet.
Yeah.
Okay, thank you. Can you kick me an email? Send me an email to remind me, and then we'll follow up from here. Sorry about that. Thank you. Cheers. Don't. I'll do it.